Alright, I want to go over a few things about sequence and series. You are going to have to find the first 5 terms of a sequence, and both a regularly defined sequence and a recursively defined one. For each of these, I want you to set up the terms. So I know some of you possess calculators that'll do sequences, so I want you to actually show me that, A1 is 6 times 1 over 3 times 1 squared minus 1. You do not have to do all the arithmetic from here, so feel free to put that in your calculator and just give me a number back. So I have 6 over 3 minus 1 gives me 2, or 3 for the first term. A2 would be 6 times 2 over 3 times 2 squared minus 1 gives me 12 on the top. 2 squared is 4, so 12 minus 1 on the bottom gives me 11. So A3, 6 times 3 on the top, 3 times 3 squared, minus 1 on the bottom. So 18 on the top. 3 squared is 9 times 3 is 27, minus 1 gives me 26. And I can do 9 over 13 here. So, and so on and so forth. So if this says the first 5 terms, just be careful that you list out A4, A5, and so on. And you can use your calculator to help you along there. You also have to find some terms of a recursively defined sequence. So remember, those are the ones that use the previous term to define the next term. So A1 is given. It's 28, and A2, we use this AN formula, means AN minus 1 means the term prior. So if I'm looking for A2, then that would be A1, and plus 2N, so 2 times 2, and 28 plus 4 gives me 32 for A2. Now, recursive formulas, you need each term to get to the next one. So A3 would be A2 plus 2 times 3, or 32 plus 6 gives me 38. A4 would be A3 plus 2 times 4, 38 plus 8 gives me 46, and A5, A4 plus 2 times 5, which gives me 46 plus 10, or 56. Of a sequence, so this is a small sum, and I don't know what this character is, I don't know what it did, but k is equal to 1 to 5 of 3k minus 4. Now, we learned a couple different ways to do this sum. If we use the formulas for k and for a constant, then this would mean that we have 3 times the sum of k from k is equal to 1 to 5 minus the sum from k is equal to 1 to 5 of 4. So the formula for the sum of k is equal to n times n plus 1 over 2, where n is the number on the top. So here this would be 3 times 5, 5 plus 1 over 2, minus the sum of a constant is always the constant times the terms. So here I have 3, and on the inside I get 5 times 6, or 30 over 2, or 15, minus 20, or 45, minus 20 gives me 25. If I forget how to do this, I can always list out the first 5 terms and then add them up that way. This is actually an arithmetic sequence, so I can also find it by doing the s, or the n over 2 times a1 plus an. So find the first 3 terms and the common difference of the arithmetic sequence. A4 is equal to 16 and A10 is equal to 46. So this is the kind where we can set up a system of equations. So if I'm thinking about this type of sequence, an is equal to a1 plus n minus 1 times d. And you'll be given this particular formula for your test. So if I want to use that, then a4 is equal to 16 gives me 16 equal to a1 plus 4 minus 1 times d. And the second one, a10 is equal to 46. So 46 is equal to a1 plus 10 minus 1 times d. If I want to simplify these, that means that I have 16 equal to a1 plus 3d and 46 equal to a1 plus 9d. Now I'm going to solve this like a system of equations, so multiplying this one by negative 1 gives me negative 16 equal to negative a1 minus 3d, and I can add those together. So 30 is equal to 6d gives me 5 equal to d. So d is equal to 5. Now I could go backwards from a4 and figure out what all of those other terms are, or I can solve for a1. So if I look at solving for a1, then you can use either of these equations. 16 is equal to a1 plus 3 times 5, so 15. Subtracting from both sides, you get 1 equal to a1. So a1 is 1, which gives me a2 equal to 6. a3 equal to 11. And if I were to add 5 again, I'd get 16, which is a4, and that's what I wanted. Alright, looking at this next sequence, find the definition an for the geometric sequence and find the 8th term of the sequence. So if I want to find the definition formula first, for a geometric I need r. So r is the number I multiply by one term by to get to the next. So looking at this, I know that I have to multiply by 4 on the bottom to make 8. The next one I also am multiplying by 4, but I've got positive, negative on the top. So this r is equal to negative 1/4. And then the other thing that I need for an is a1. So a1 is equal to the first term, or 1/2. Now an for a geometric is equal to a1 times r to the n minus 1 power. So I'm just going to fill that in. an is equal to a1, which is 1/2, and r is negative 1/4 to the power n minus 1. When you have a lot of fractions, I like parentheses. It makes it easier to understand what's being raised to a power and what's multiplied by what. Alright, looking at the rest of the problem, it says, and find the 8th term of the sequence. So a8 would be 1/2 times negative 1/4 to the 8 minus 1, or to the 7th. And I have 1/2. So negative 1 to the 7th on the top, and 4 to the 7th on the bottom. I'm going to plug in 4 to the 7th on my calculator because I certainly don't know it off the top of my head. And I get 16,384. So 1/2. Negative 1 to the 7th power is an odd power. So I have negative 1 on the top and 16,384 on the bottom. Multiplying it gives me negative 1 over 32,768. It's a big number. Actually, it's a really small number, but big number on the bottom. All right, last couple things we have are some sums and some completing the square. You will have to complete the square on this test. All right, looking at this first one, I have the sum from 1 to infinity of 3 times 1/3 to the n minus 1. So we've done a comparable formula, so starting at n is equal to 0 and going to a power of n, the formula works both ways. So an infinite sum exists if our R value is between -1 and 1. Or the absolute value of R is less than 1. Here R is equal to 1/3. So if that sum exists, then the sum is equal to A1 divided by 1 minus R. So I'm going to go through, and A1 here would be 3. 1/3 is R. So this is equal to 3 over 2/3. Multiplying, so 3 over 1 times 2 over 3 gives me 9 halves. And that's my sum. Remember that that's not actually the number that it adds up to, it's the number that you put a cap on it and it never gets to. Finding the sum of the sequence, this is a finite sequence, so the formula for the finite sequence, and you will have a formula sheet. Let me show you the formula sheet. Oops, I will post it to e-learning. But you will have a formula sheet here. It looks something like this, and I will post it to e-learning today. And it gives you the sum of the finite sequence, and it's A1 times 1 minus R to the n over 1 minus R. So if I want to fill in this formula, I need the first term. A1 here is always equal to 5, so this is 5. And we have 1 minus R here is -5 halves. Notice that if this one was infinite, it wouldn't exist because 5 halves is greater than 1. So -5 halves to the n, so power of 6, and 1 minus -5 halves. Alright, we have to simplify this. So 1 minus, this is an even power, so it's going to end up being positive. And on the top I have 5 to the 6th power, or 15/625. On the bottom, 2 to the 6th, which is 64. And then on the bottom, I have 1 plus 5 halves, so 2 over 2 plus 5 over 2 gives me 7 over 2. Alright, so we did one where it had a 1 on the top in class. This one has 15,625 on the top. Doesn't work exactly the same way. So, but I do know that 1 is equal to 64 over 64. So if I'm going to simplify this fraction, then 64 over 64 minus 15,625 over 64 and 7 halves. So 64 minus 15,625 gives me 5 on the outside. On the inside, I have -15561 over 64, and I'm flipping the bottom, 2 over 7. 15561, let's see if it's divisible by 7, and it is. So I have 2223, still negative, and 64 gives me 32. And not divisible by 32. So 5 times 2223 gives me -11115 over 32 for my final answer. And that's my sum. A lot of arithmetic there. The concept is not real difficult if you can plug in your values of A1 and R, but the arithmetic you have to crunch through. Alright, completing the square to put the conic section in standard form. So you did this in lab, and I want to group my x variables and my y variables first. So 3x squared minus 4x, and I have minus 4y squared plus 2y, and I'm going to bring this over is equal to negative 1. Alright, I'm going to pull the coefficients out to the front. So 3 times x squared minus 4/3 x, and I'm going to do something, and 4 y squared. I'm pulling a negative 4 out to the front, so I need to change this into 2/4, 1/2 y is equal to negative 1. Now I need to figure out what's going to be in my parentheses here so I know what to add. So I'm taking the term out in the center, and it's negative 4/3 here. So negative 4/3, and I'm dividing that by 2. So far I have negative 4/6, and I'm going to square it. So squaring that, 4 squared gives me 16, 36 on the bottom. It's positive because it's negative being squared. So I end up with plus 16/36. I didn't simplify it yet. I probably will, but I didn't yet. Now what I add to the other side is really that times the 3 on the front. So remember, you have the 3 on the front, so times 3 here. If I multiply by 3, I'm going to end up with 12 on the bottom, and I have plus 16/12. Now I'm going to do the same thing with my y component, so I'm taking the number here out of the center, and I have negative 1/2, so negative 1/2 divided by 2 gives me negative 1/4, and I need to square it. So I have 1 on the top, 16 on the bottom, and that's what I have on the inside. Now what I actually have is that times negative 4. So this gives me negative 1/4. So what I do to one side, I have to do to the other. Alright, completing the square part is done. Now I factor. So I have x minus whatever it is I squared, so minus 4/6 or minus 3/2. Oh, that's not 4/6. Let's do that again. Minus 2/3 squared, and then minus 4, and y minus 1/4 squared is equal to, on the other side I need to reduce my fractions, or I need to work on a common denominator. So if I work on a common denominator, I'm just looking at this part. So negative, I'm going to turn it all into 12ths. 12/12 plus 16/12 minus 3/12. Negative 15 positive 16 gives me 1/12. Alright, so when you're dealing with a conic section, it has to be equal to 1. So I am multiplying this whole thing by 12 so that I can get 1. And if I multiply everything by 12, 12 times 3 gives me 36. X minus 2/3 squared. And 12 times 4 is 48. Y minus 1/4 squared is equal to 1. Multiplying by 36 is like dividing by 1/36. So this in an equivalent form, x minus 2/3 squared divided by 1/36 minus y minus 1/4 squared and 1/48 is equal to 1. and my square is completed. All right, have a good weekend. We'll come in for review tomorrow, and I will send out an email with all kinds of details. Thank you.